In this video, we're going to look at the Exam 2 Review worksheet, and we're going to look at the first one. So starting with exercise 1, it reads, it's known that when a specific type of radish is grown in a certain manner without fertilizer, the weights of the radishes produced are normally distributed with a mean of 40 grams and a standard deviation of 10 grams. So first of all, notice here what they're telling us about is one type of radish, and that is the type without the fertilizer. And then it tells us about the population distribution for these types of radishes. We know that it's normally distributed with a mean of 40 grams and a standard deviation of 10. When the same type of radish is grown the same way except for the inclusion of fertilizer, so now we're being told how this radish behaves with fertilizer, it is known that the weights of the radishes produced are normally distributed with a mean of 140 grams and a standard deviation of 40. So notice again, we're told about this population's distribution is normally distributed, and we get the mean and the standard deviation. So the first thing we're going to do is draw the two different distributions. So on the left, I'm going to draw the without fertilizer distribution. And on the right, I'm going to draw the fertilizer distribution. And the without fertilizer, I'm going to use the random variable x, and for the with, the random variable y. And that'll help me with my probability notation later on. So looking at the without fertilizer distribution, we know that it's normally distributed, so we've got our bell-shaped curve. We also know that it has a mean of 40, so 40 will be in the center. And we have a standard deviation equal to 10. For the with fertilizer group, again, we're told it's normally distributed, so we've got our bell-shaped curve. And we're told that this group has a mean of 140 with a standard deviation of 40. All right, so now we're going to answer some questions. So the first one, or for all of them, it says determine the proportion of radishes grown and give the appropriate probability notation for each of the scenarios. So looking at scenario A, we have without fertilizer, so we know we're going to work with this distribution, and we want to know what proportion has weights less than 50 grams. So we're going to start out by drawing our distribution and shading in the area we're interested in. So again, since we're working with the without fertilizer group, we know it's centered at 40. The value we are interested in is 50 grams. 50 lies to the right of 40. And we want less than 50 grams. So looking at our curve, the area that we're interested in is all of the area to the left of 50 grams. So in other words, we're going to try to figure out what this area is. So to do that, we first need to find our z-score. So we know that z is equal to 50 minus the mean divided by the standard deviation, which is equal to 1. And then the next thing we can do is we can use our standard normal table. And remember that your standard normal table will always tell you the area to the left. So looking at our standard normal table, here is our z-score of 1, and it has 0.8413 area to the left. So in terms of probability notation, we know the probability that the variable we're interested in, which is x, being less than or equal to 50, is equal to 0.8413. All right, our next question says with fertilizer, so we're going to work with the second distribution, with weights less than 60 grams. So again, I'm going to draw my distribution. This one is centered at 140. And I'm interested in less than 60. Well, 60 lies to the left of 140. And then I'm interested in less than, so I'm going to shade in the area to the left of 60. So again, I'm going to calculate my z-score. Now when we look up -2 on our z-chart, it's going to give me the area to the left. So again, we want to pull out our z-score chart. Here we go. And we find to the left of -2, we have 0.0228. So this area right here is 0.0228. So now we know the probability that y is less than or equal to 60. And we're using y in this case because we're with the with fertilizer group, is equal to 0.0228. Next, we're going to look at the with and without fertilizer with weights between 20 and 60. So we've got two different problems we're going to solve. So I'm going to draw the line here so that I've got room for both of them. So again, I'm going to draw my picture. So I'm going to start with the with group. So we're going to be on this side right here. I'm going to draw my curve. And notice I'm interested in between 20 and 60. Both of which are to the left of 140. And I'm interested in the area between these two. Well, up above, we already found all of the area to the left of 60. So that's all of this. So if we find the area to the left of 20, we can take the area to the left of 60 minus the piece we don't want, and that will give us the piece we do want. So let's find the z-score for 20. Okay. Looking up that z-score, we have to the left of -3, 0.0013. So this area right here is 0.0013. So the probability that y is between 20 and 60 is going to be equal to 0.0228 minus 0.0013. And so if we take a moment and we put that in our calculator, we find that's equal to 0.0215. All right, we can do the same thing for the without fertilizer group. So this was the with, and this one will be the without. So again, I'm going to draw my curve. This time the curve is centered at 40. And I'm interested in between 20 and 60. Now there are two different ways that we could solve this problem. We could do something similar to what we did before. We could find the area to the left of 60 and subtract off the area to the left of 20. Or alternatively, notice in this case our standard deviation was 10. So 60 is 2 standard deviations above 40, 20 is 2 standard deviations below. So using the empirical rule, we know that approximately 0.95 of the area falls between these two. So in other words, the probability that x is between 20 and 60 is equal to 0.95. And if you use the z-table, you'll find something very similar. Using the z-table, you would find that the probability is 0.9544. All right. And then we've got one more problem here. So again, we're going to do with and without fertilizer. So we're going to have two different curves here. And we want to find weights greater than or equal to 60 grams. So we'll start with the with group. So again, drawing our curve. 60 lies to the left of 140. And we want the area greater than . Well, notice in part B, we already found that this area was 0.0228, so this area has to be 1 minus 0.0228. So in other words, the probability that y is greater than or equal to 60 is equal to 1 minus 0.0228, which is equal to 0.9772. For the without group, again, we can draw our curve. And we're interested in the proportion above 60. Well, notice up here, we know that between 20 and 60 is 0.95. So if 0.95 is in the center, if we split the remaining 0.05 between the two tails, this tells us that between the two tails, we have 0.025. So therefore, the probability that x is greater than or equal to 60 is equal to 0.025. Now, this is what you would get using the empirical rule. If you use the standard normal table, you will get something that is very similar to this. All right, looking at the next page. So recall that the letter Z is used to denote a standard normal random variable. We're going to find the requested area, and we're going to fill in the probability statements. Whenever we work with a standard normal curve, remember that the curve is centered at 0. So we want the area above Z is equal to negative 1.5. So the first thing we're going to do is look up negative 1.5 on our table. So looking up negative 1.5 on our table, we find the area to the left is 0.0668. Therefore, the area to the right has to be 1 minus 0.0668. And so if we put that in our calculators, we'll find that's equal to 0.9332. Doing something similar for the next one. Again, this is a standard normal, so it's centered at 0. We've got negative 0.14 is somewhere to the left. And this time we want the area below. So we're going to look up negative 0.14 on our table. So we have, down here at the bottom, negative 0.1, and we go over to 4, which gives us 0.4443. So the table always gives us the area to the left, which this time is the area we want. So there's our answer. For exercise 3, women's heights have a mean of 63.6 inches and a standard deviation of 2.5. Find the z-score corresponding to a woman with height 70 inches and determine whether height is unusual. So remember that the z-score is equal to the value we are interested in minus the mean divided by the standard deviation. And if we put that in our calculator, you get 2.56. Notice that 2.56 is less than 3. Generally, we consider values either less than negative 3 or greater than 3 to be extreme. So for this case, we would not consider this to be an extreme value or an unusual value. For question 4, we're going to do something very similar. We're going to calculate the z-scores for each of these. So I'm going to go ahead and fill those in. So notice of these, part C has the largest z-score, so this student has the highest relative score. This concludes this video.